Today we're going to learn about segments. So as part of that, we're going to be reviewing midpoint, and then we're going to be going over the vocabulary words segment addition postulate and segment bisector. So this is a review of the midpoint formula and the midpoint. Remember that the midpoint is just a point in the middle of a segment. If you're given the coordinates of the endpoints, then to find the midpoint, you would plug it into the formula. This was the formula that was given to you earlier. And you would plug that in, and that gives you the coordinate of that point, which is the midpoint. Remember that the midpoint separates or cuts this in half. And so if I gave you the entire length of the segment, like 10, then it would split it so that each section was just 5. The tick marks that are drawn here in blue also represent that these two are congruent, and the symbol is right here for congruent. We're going to use midpoint for the next vocabulary word. Our new vocabulary word is segment bisector. A segment bisector. So let's take this word, and instead of just going over the definition, let's look into it. Bi means two, and sect means like section, so 2 parts. So I want you to think 2 parts. And if you have an OR at the end, that means that is the person or the thing that does it. So this is something that cuts a segment into 2 parts, and they are both going to be congruent, the 2 parts. So it cuts it exactly in half. Who does this could either be another segment or a ray or a line. Technically, it could also be a plane. We don't really go into depth with that in geometry, but I'm just wanting to put it out there. So it divides it into 2 congruent parts. So let's look at this top segment right here. I think the middle is about right there. That little dot would represent the midpoint. But what we're learning today is we're learning about the bisector, the thing that cuts this in half. So it could either be a segment. If it were a segment, it would have 2 points at each end. Or it could be a ray. That means 1 arrow. Or it could be a line. And if it were a line, it'd have 2 arrows, 1 on each end. So if I'm going to name it, I'll name it line L for right now. Then line L is known as a segment bisector. Let's look at the bottom one. So the only reason why I drew 2 examples is because I wanted to show you a different way that you could bisect this. You could bisect this segment any way. The problem is once it's bisected, these are the only 2 that are congruent. But this black line right here is not bisected himself. Just the blue one, which is segment AB. At this point is point M, which represents midpoint, so I already drew it. But let's say it were a line or a ray. It's not cut in half. So this is the one that's not bisected. He is the bisector. So he's like doing the one that's cutting. For example, like scissor. A scissor is the one that does the cutting. He doesn't get cut in half. The bisector is the one that cuts the segment in half. He does not get cut in half. he is not broken into two congruent parts. So you just have to focus and remember that these are the ones that are congruent, not the bisector himself. The one that I drew is a specific bisector. He's actually making a 90-degree angle, which is known as a perpendicular bisector, but we'll go more into that on the next section. And our last vocabulary word is segment addition postulate. It's very simple. I'll go over it, but I'm just going to basically show you in a picture, which will make a lot of sense. So the definition just says if D, E, and F are collinear. So remember, collinear, co means together, linear means line. So that means together on the same line. And they are saying E is between D and F. So if we're going in the picture, just have D, E, and F on the same line. All three of these points are all on the same line, so they are collinear. E is between the two. Then you could say that segment DE plus segment EF equals DF. All they're saying is if you're taking one segment right here, so this segment plus this segment, if you're taking the two segments, you can add them together. That's what the addition symbol says. You can take the two symbols or the two segments, add them together, and it equals the entire segment. So that's all it's saying. So it equals the entire thing. Let's use this with numbers. So for example, if this was length, I don't know the way I put the point. Let's just say this was 3 units and this was about 7 units. That means if you were to find the length of DF, which is the entire thing, then you would just take 3 plus 7 and add it, and done. So the entire length is 10. Now let's do a real example of what you would normally see in a geometry problem. Let's put the point over here. Let's say there's 3 points. I could break it up into more, but just for right now, let's just do some basic problems. And I'm going to call this A, B, and C. Normally, you're going to have problems like this with a variable. And then I would tell you something like, oh, the entire length is 10. But of course, it's not always going to be that easy. You're going to have problems with x, or maybe it'll be like 3x, and you're going to have to find x. So the way you would do this is you would set it up as an equation. So segment addition postulate says you can add the two parts, so this part plus this part, and it equals the whole shebang, which is the 10. Set that up as an algebraic equation. So 7 plus 3x equals 10. And now go ahead and solve for x. And you'll get 3x equals 3. And your final answer is x equals 1. Just warning you, in geometry, you're going to always take it probably one more step. And what if you were to find BC? If you had to find the measurement of BC, so I'm going to put a little m here for measurement. To find the measurement of BC, you would have to take the 1 and plug it back in. A lot of times in geometry, you're plugging stuff back in. So you take x equals 1, plug it back in here, which is a 1. 3 times 1 is 3. And you would put that in. A quick disclaimer. In geometry, a lot of times, you're going to have problems. We don't have to do this one, but I just wanted to show you that A lot of times it says figure is not drawn to scale. What that means is I don't want you assuming a picture is drawn a particular way or a particular length. So if you're looking at all three of these pictures that I've given you, these are all problems that you're going to be doing soon. And I want you to look at them. I don't want you to assume anything. Don't think your teacher drew it wrong or they put it exactly a certain way. You never know. For example, if you're looking at this problem right here in the center, don't think that I made a mistake and that point should really be in the middle. I kind of put it off on the side on purpose. But if you're looking at the problem right here on the right, I'm not sure it shows that it's exactly in the middle. That's why directions are very important. Always read the directions first. Do not assume that it is exactly in the middle. Do not assume that what's drawn is a midpoint. Do not assume that something is a bisector unless it's given to you. When you are given a problem, before you start solving, I want you to look at these following words that will help you and guide you to see how to set up the problem. Does it have the word congruent in there? That would be helpful in setting up your problem. Congruent means they would be equal to each other. Does it have tick marks in your problem? Same thing. If there are tick marks, like for example in this problem, these are tick marks, then that means you would probably set some things equal to each other. Bisector, if it has the word bisector or even the word midpoint, that does mean there's going to be some parts that are congruent. So work at that out. Right now what I'd like you to do is look at these three problems on the bottom and determine which one of these would be ones where you would take parts and you would set them equal to each other. Which ones would you set equal to each other? Well, I kind of gave you the first one. I showed you these are congruent marks. So if you were to set up this problem, you would set them equal to each other. In the third one, there is the word midpoint. Midpoint does mean set them equal to each other. So when you're solving this problem, you would take 5x minus 6 and you would set it equal to 2x in order to find the value of x. That leaves us with that third problem, the one in the middle. What do I do with this problem? So, all else fails. When you don't know what to do, use the segment addition postulate. So in this problem right here, I would have to take the two pieces, this piece and this piece, and add it together. So that means I'm going to have to take x plus 4 and add the other segment, which is 4. But what do they equal? It equals the whole segment, the whole shebang, which they show you, that's at the bottom, the 3x plus 2. I'm gonna stop right there because that leads us off into tomorrow's lesson.